Welcome back. This week we're talking about publishing and replicability. So throughout this semester, you have worked towards writing the kind of APA style paper that any behavioral researcher would write. So if this weren't just for course credit, what would you do next? You don't just let the paper sit on your desktop collecting the digital dust, you instead publish it. The ultimate goal of any research is to share knowledge, to spark further inquiry, and to contribute to the broader scientific conversation. Publishing your work allows others to learn from your findings, to build on your insights, and to apply your discoveries to real-world challenges. It's your opportunity to add your voice to the scholarly community. So once your research is polished and written up, the next step is submission. Typically, a manuscript is sent to one journal at a time for consideration, and from there, the editor of the journal takes over, assigning your paper to a team of 2 to 4 expert reviewers. These are known as peer reviewers, and they're called peers because they usually are people in the same field with similar knowledge backgrounds, so they can provide an informed critique of whatever paper you write. These peer reviewers evaluate the rigor, the originality, and the significance of your work, and then their feedback becomes a key part of the publishing process. This is where your journey from a researcher to a published author truly begins. Peer reviewers provide detailed feedback aimed at strengthening your manuscript and ensuring that it meets the standards of the field. Their comments may address the clarity, organization of your writing, the soundness of your methods, validity of your conclusions, and the originality and significance of your findings. They might suggest adding or revising references, clarifying arguments, expanding on data analysis, or correcting technical terms. And while the tone and depth of feedback can vary, the goal is always to improve the quality and impact of your work before it is shared with a broader audience. When this manuscript is submitted for publication, the reviewers and editors look for several key elements that signal quality and impact. One of the first things they consider is the significance of the research question. Does it address any important issue within the field, and does it have the potential to make a meaningful contribution to society? A strong paper goes beyond just repeating what's already known, and instead pushes the boundaries of understanding in a relevant and timely way. Novelty and interestingness are also critical factors. Editors want to publish work that offers something new. Whether it's a unique perspective, a fresh theoretical approach, or original findings, reviewers are drawn to papers that pose intriguing questions or present surprising results that challenge the assumptions. It's not just about being different, it's about offering insights that engage readers and advance the conversation in the field. And beyond the scope itself, the quality of the methods and analysis is vital. Reviewers examine the study design and demonstrates high construct, internal and external validity, which are all things we've talked about, which are the relative accuracy of the measures, what it claims to do, is it well controlled, is it applicable beyond the specific sample. Analyses that you do must be appropriate for the research questions, and any interpretations should align with the data. Finally, strong writing ties it all together. Clear, organized, and engaging communication ensures that your ideas are not only understood, but also appreciated. Just because you have a good idea doesn't mean that it's going to get published. It also has to be conveyed effectively. After peer reviewers have gone through their evaluations and submitted it back to the editor steps in to make the final decision about what to do with your manuscript. There are a few possible options at this point, and the best case scenario is the accept as is. Though this is pretty rare, but definitely worth celebrating. If this happens, throw a party because this is awesome. You're done, one and done. But more commonly, you might receive something like accept with minor revisions, which just means a few adjustments are needed before the publication. But the more common one is the revise for invited resubmission, the revise and resubmit, as it's called shorthand, which means the journal sees potential but wants more substantial changes before making a final decision about whether to publish your article. Of course, there's always the possibility of a rejection, which can be really tough. Hopefully no reviewer writes that your manuscript sucks, but they will give you feedback that says this just isn't right for the journal, and this can be tough, but it is a normal part of the process. Generally, you can take that information, revise it, and send it somewhere else. It's important to recognize that this entire review and decision cycle does not happen overnight. In most cases, this process takes anywhere from 3 to 6 months, sometimes even longer, sometimes it can take years. And reviewers are balancing your paper alongside what they're doing as their own, because they're peers, so they're doing their own research right now too. Those are faculty out there who have to do teaching and research. And so they have other responsibilities that might take a while to get that review back. And the editor also needs time to get all that feedback, weigh it carefully, and then make the final decision. This is why patience and persistence are absolutely essential qualities for any researcher who is aiming to publish. A rejection doesn't mean the end of the road. It's actually thought of more as an opportunity to improve your work and to try again. This could be with the same journal or maybe a different one that might fit better for whatever your research was. It's kind of like submitting a paper to your professor, finding out you got a grade lower than what you desired, but then they give you another opportunity to revise and resubmit that paper for a potentially higher grade. That is, assuming you took in their feedback. So successful academic publishing is as much about resilience as it is about great writing and research. Now, publishing is often considered the cornerstone of academic success, summed up by the well-known phrase, publish or perish. While there are other ways to contribute to a person's field, like presenting at conferences, or teaching, or just collaborating on some kind of grant, publishing peer-reviewed work remains the most critical. It is the primary way that scholars demonstrate productivity, they build their reputations, and advance their careers. Without any kind of solid publication record, it can be difficult to secure funding, to earn tenure, or to gain recognition within one's discipline. More than just career development, publishing also plays a central role in the process of science and scholarship. It allows your work to be rigorously reviewed, validated, and shared with others in the field. So by publishing, you are formally entering the scholarly conversation, giving others the opportunity to learn from challenges or the ways that you've built upon your findings. This exchange of knowledge is what fuels academic innovation and ensures that good ideas don't remain isolated. Now, once your research is published, it becomes part of the academic record, and it's accessible to scholars around the world who are working on related questions or teaching the next generation of students. This visibility increases your impact and allows your work to contribute to future studies, to maybe even policy changes or practical applications. Ultimately, publishing transforms your individual efforts into a lasting contribution to your field and to society at large. So it's great. Now, with all that feel good about publishing and how great it is, though, it's important to remember that science is not a one and done endeavor. It's cyclical, like we talked about in the first lecture. It's an ongoing process that has theories that are tested, and the data either confirms or doesn't confirm that theory, and we got to do more. No single study can provide all the answers or claim absolute truth. Instead, each piece of research contributes a small but valuable part to a much larger puzzle. Scientific knowledge evolves through constant reevaluation, replication, and refinement. When findings are confirmed across multiple studies and contexts, our confidence in those conclusions grow, and when they aren't, it prompts new questions, deeper investigations, and sometimes it just shifts our understanding entirely. This is why publishing research is so crucial. It allows others to scrutinize, to test, to critique, to expand upon your work. One study might lay a foundation, another might replicate it under new conditions, and yet another might challenge or revise it. Over time, this process helps to inform and shape broader theories, and it's not about being right in a single paper, about finding the perfect thing that everybody says, yes, you are the best researcher. Instead, it's about contributing to a collective, self-correcting body of knowledge. As scientists and scholars, our role is to keep that cycle going with transparency, rigor, and curiosity. So, if science is constantly building upon itself, then we should also consider how researchers go back and confirm previous knowledge. One researcher might find an effect between two variables and they publish their results. But then another researcher comes along and finds the opposite effect. So how do we as scientists deal with this conflict in findings? One way is to attempt to confirm the findings from one or both of those studies another time, to redo it. And no study is perfect, so the findings from one study may reflect actual effects of the real world, or of course there's a chance that they are due to some kind of error. That's what we called type 1 error, if you remember, when we reject the null hypothesis when we shouldn't have. But if multiple researchers run the same study and find the same results, then we have more evidence that the effect does exist in the real world. So scientists are always constantly attempting to reconfirm the findings from previous studies. So this all brings us to the issue of replicability. Replicability refers to the idea that if the same study were conducted again under the same conditions, would it produce the same results? This is essentially a test of a study's reliability. Replication is just a reliability test. That is, can its findings be trusted to hold up over time? It's like a test-retest kind of thing. We want to know if it can be over time, across different samples, or when carried out by other researchers. Replicable results are a hallmark of solid, dependable science. If you can redo it and it's reliable, then we can trust that effect more. But this raises important questions. What do we really mean by the same study? Is it repeating the exact same procedures with a new sample? Does it include the same measures or the same setting or the same statistical analyses? Defining what counts as truly same study isn't always straightforward, and slight changes in design or population can sometimes lead to very different outcomes. This is why careful documentation of methods and materials is so important when you publish your research or when anybody publishes research, so that others can understand exactly what was done and then try to reproduce it accurately. We also have to consider what we mean by the same results. Are we looking for identical statistical outcomes? What about similar effect sizes, or is it just consistent direction of the results? Sometimes replication studies find smaller or less significant effects, which doesn't necessarily mean the original study was wrong. It could just reflect natural variation. Replicability isn't about demanding perfection. It's about building confidence in findings through repeated observation. When results replicate consistently, they become more reliable building blocks for theory and future research. In order to highlight the different ways that we can look at replication and address some of these issues of what are we evaluating, for the next few slides, we are going to use a running example that's pulled from real research. The original investigators were interested in whether subconscious priming could alter visible behaviors. So to test this, they designed a study that would prime people in some way and see if the behaviors matched the intended priming. The actual study went something like this. Participants are told they're completing a language task, and they're given a list of scrambled sentences to unscramble, like bingo the played she, or sky the blue is. What the participants didn't know is that the sentences are subtly designed to include words that relate to the elderly, words like retired, or Florida, or gray, and wrinkle. This is the elderly priming condition. In the control group, participants see neutral words with no age-related connotations, like blue. There's nothing there. After the word task, participants are told the study is over, and they're casually observed as they walk down the hallway to leave. The dependent variable here, that outcome that we care about, is the speed at which they walk, which is secretly timed by another research assistant. The hypothesis here is that the people who are primed with those elderly related words, the bingo, wrinkles, gray alone, those people will walk more slowly than those in the neutral condition. This is suggesting that there's some kind of subtle unconscious cue that can influence physical behavior. This example provides a compelling way to explore concepts like priming, which is independent and dependent variables that have some issues with replicability. Now, to be clear, this is an actual study by a guy named John Barge. It was done in the mid-90s, and it made a lot of waves in the field of subconscious priming when it was published. You might have even talked about this study in your Introduction to Psychology course, but we're talking about it now because as time went on, researchers in the field began to question the findings and maybe began to have trouble finding evidence of priming. And thus researchers started exploring whether they could replicate these findings. One way researchers could attempt to replicate the findings is through a direct replication. That is, by repeating the original methods as closely as possible. This means using the same scrambled sentence task with the same or very similar elderly related and neutral word lists, and the same cover story, and the same procedure for measuring how quickly participants walk after completing the task. All of the things have to be the same. It's like an exact direct replication. The goal is to keep everything as consistent as possible, except of course for the participants themselves because it's a new time. By using a new sample, researchers can test whether the original findings hold up in a different group of people, which provides a lot of external validity there. The primary goal of this direct replication is to see whether the effects found in the original study, which is, again, the idea that priming people with elderly related words makes them walk more slowly, was a generalizable psychological phenomenon? Or is it just something that only occurred with that particular group at that particular time or under those specific conditions? If the result replicates in a new sample, it increases confidence that the effect is real and robust. If it doesn't, of course, it may suggest that the original finding was more context specific or perhaps even a false positive, that type 1 error. A secondary but important goal of direct replication is to help ensure that the original results weren't due to any kind of questionable research practices, such as you may have heard of p-hacking or selective reporting, or even cases of outright fraud. By following the same procedures and looking for the same effect, direct replications serve as a form of scientific accountability. They help maintain the integrity of the research process and provide a check on the reliability of published findings. Another effective approach to following up on the elderly priming study is through a conceptual replication. This means that rather than repeating the exact procedure, we can test the same theoretical idea. Again, here it is whether priming influences behavior consistent with age-related stereotypes. And this time, instead of doing it directly, we use different methods. This allows us to see if the effects hold up across varied controls and contexts rather than being tied to a specific set of experimental conditions. All of those things don't have to be exact to get this phenomenon to appear. So one example might be that we might swap out the original measures of walking speed and instead time how long participants take to complete a simple, unrelated task after the priming. The theoretical expectation remains the same, that exposure to these elderly related words might unconsciously lead to slower behaviors. It takes longer to complete a task. By changing the behavioral outcome from the physical movement to the task duration, we're still examining the core prediction, which of course is that priming of elderly words consistent with the behavior, while addressing potential limitations or variability that are tied to measuring walking speed. We could also do it that instead of using scrambled sentence tasks with words associated with the elderly, researchers could also expose participants to a series of images that feature slow-moving animals like turtles or sloths. The theoretical mechanism remains the same, which is that subtle exposure to concepts associated with slowness, once elderly, now it's just pictures, may unconsciously influence subsequent behavior. This approach maintains the core idea of priming without relying on linguistic processing, which offers a different route to stereotype activation. By observing whether participants who viewed slow animal images behave more slowly on a follow-up task, such as moving more slowly or speaking with a reduced pace or completing a simple reaction time test with more delay, we can then evaluate whether the priming effect generalizes across different modes. If similar behaviors, similar slowing behavior occurs, it would suggest that the priming mechanism operates not just through a semantic word cue, but also through visual associations. This added layer of priming works in other situations reinforces the broader theoretical claim about the influence of concept activation on behavior. It just says there's lots of ways that if we can be subconsciously primed to change our behavior. Now, so what we've seen is two just brief examples. I've kind of dropped a few more, but this kind of variation strengthens our understanding of the original finding by showing whether the effect is robust across different operationalizations. Remember, we talked about operationalizing is just how we measure. So we're just measuring different, we're manipulating different with the same idea. If participants primed with these elderly concepts consistently slowed or showed slower task performance, it suggests the broader claim about stereotypical activation affecting behavior. It still happens even when the specific mechanisms, the specific outcomes differ. Conceptual replication can also be used to test the opposite direction, of course, the opposite of the theoretical prediction. So this provides a more complete understanding of the underlying mechanism if we see not only does it work one way, but in the other as well. Though in the context of this example with the elderly priming study, this would involve examining whether priming participants with concepts associated with going fast, such as words like race or cheetah or greyhound, leads to faster walking speeds. See, it's the opposite. Before it was slow elderly words to see if that causes faster or slower behavior. Now we're switching it up and we're priming differently. Maybe we could use young words too to see if those are associated with speed. We want to see if there's quicker behavior, faster walking speeds in general. While the original study focused on the idea that exposure to slow concepts would result in slower movement, the flipped approach explores whether activating fast concepts produces the inverse effect. This type of conceptual replication strengthens the original study by demonstrating that priming doesn't just influence behavior in one direction, but that the effect follows a consistent logic depending on the nature of the activated concept. If participants exposed to speed-related words consistently walk faster or complete tasks more quickly than the neutral control group, it supports the idea that the priming effect reflects general behavioral alignment with the activated subconscious prime, rather than maybe it's just an artifact or something weird happening, some type 1 error. So doing it in this new conceptual replication, looking at the concept from a different angle, can be very important to replication. The final version of conceptual replication that I want to talk about can involve testing the same underlying psychological mechanism, such as the priming effects on behavior, but it uses entirely different manipulations and dependent variables. You're changing everything. The only thing that's still there is the theory. For instance, instead of priming individuals with words or images related to aging or speed, researchers might present participants with national symbols like a country's flag or patriotic imagery. The hypothesis here is that subtle exposure to national identity would activate related values or attitudes, such as maybe the civic duty or political affiliation, which might then influence behaviors like voting preference or turnout intentions. So basically, instead of looking at does priming with slow ideas cause people to move more slowly, it's does priming with nationalistic ideas prime people to do nationalistic things like vote again. In this version of a conceptual replication, both the prime, which in this case is the national symbols instead of the semantic word cues, and then the outcome measure, which is voting here instead of the walking speed, these are changed. Yet the core idea remains the same. This is the subtle, incidental cues in the environment that may unconsciously shape meaningful behavior. If individuals exposed to a national flag are more likely to endorse patriotic policies or support mainstream political candidates or even express stronger intent to vote, it supports the broader theory that priming can in fact guide behavior through automatic activation of related mental constructs. This approach highlights the flexibility and range of priming as a psychological mechanism while testing its relevance in real-world domains. So again, we've talked about lots of different ways we can do this conceptual. All of them boil down to looking at the same theory, and we're just switching up a little bit of the IV or the DV around how we measure them, but not the underlying theory. So those are the various forms of conceptual replication where researchers are attempting to study the same theoretical phenomenon using different methodology. But another valuable approach that's slightly different is the replication plus extension. This involves repeating the original methods while adding a new element to the design. Unlike a pure replication, this method tests not only whether the original effect can be reproduced, but also explores additional conditions or maybe different samples or measurements that can deepen our understanding of the phenomenon. This strategy is especially useful for identifying the boundary conditions of an effect, which is the when, for whom, and under what circumstances the effect does or does not occur. So in the context of the priming study, a replication plus extension could involve including the original elderly word priming condition and a neutral condition, but also adding a third condition, which is the priming for fast-related words, such as cheetah, dash, or greyhound. This additional manipulation allows researchers to test not only whether exposure to elderly-related words slows behavior, but also whether exposure to speed-related words speeds it up. The original procedures are maintained, but now the design offers a fuller picture of how different types of primes influence behavior in opposite directions. So we talked earlier about you could do each of these independently as a conceptual replication, but putting them together in the same study with maybe the same participants in the same study design makes it this plus extension. It's building on it. It's modifying it in ways that adds new mechanism. This extended design allows researchers to examine whether this priming effect is linear or categorical, and whether it can be generalized across different types of conceptual activation. By incorporating both ends of the conceptual spectrum, that's slow versus fast, we can better determine if the scope and limits of the priming effect exist. Like, does it only work for elderly words, or does it also work for the speedy words? It also opens the door to testing interaction effects, which we talked about with factorials, such as whether individual differences, such as maybe baseline walking speed or age, moderate the impact of the primes. In this way, replication plus extension not only reinforces or challenges the original finding, but it also moves the theory forward. It's not just finding yes or no to the past, but also what can we now learn to progress. So with all those different ways of doing a replication study in mind, it's also important for us to recognize that defining a successful replication is not always straightforward. One common approach is to look at the statistical significance of a study. That is, if the original study found a statistically significant effect, which is typically that p is less than 0.05, then we would hope a replication is often judged as successful if it also finds a significant effect in the same direction. However, this definition has limitations because statistical significance is highly sensitive to the sample size. Remember, we talked about how p is a product and power is a product of the sample size, as well as the variability in the sample. And a non-significant result in a replication doesn't necessarily mean that the original finding was false. It instead may reflect noise or insufficient power in the new study. So we can't really confirm whether or not the effect exists. A more informative approach considers effect size. That's why we spend a lot of time talking about it, that p-values are nice and statistical significance is good for drawing a line in the sand between whether something is an effect, but the actual effect size, how powerful it is, this might be more useful. These effect size tell us how strong the effect size is regardless of the sample size. Even if a replication yields a statistically significant result, it may not be considered successful if the effect size is drastically smaller, let's say, than the original. Conversely, if the replication yields a similar or consistent effect size, even without reaching that significance, there's no p-value, but the effect is the same, it may still provide support for the original finding. So just because we didn't get a statistically significant result doesn't mean we didn't find basically the similar results. So comparing the effect sizes allows for a more nuanced evaluation of whether the replication supports the original theory or whether it suggests that the original one may have been overstated. At its best, replication research involves systematic efforts across multiple settings and samples. This is seen in large-scale projects like the Many Labs Replication Project. In this initiative, there was 36 independent labs around the world who collaborated to replicate 13 high-profile psychology studies using the same materials and procedures. Everyone came together. It was great. And these direct replications across diverse populations, because they were trying to do the exact same studies in 36 different places, these direct replications provided a much clearer picture of which effects were robust, were really strong, that we found, yes, there's good evidence for this, and they were generalizable because they were able to be reproduced and replicated in 36 different places. And it also showed which were less reliable. The strength of this approach lies in its ability to separate the little differences in results from effects that truly hold up across contexts. But ultimately, a successful replication isn't just about repeating the same result. It's about building confidence in the finding through consistent patterns across different methods, samples, and measures. Both statistical outcomes and theoretical coherence matter. Replications that confirm, refine, or challenge existing conclusions all contribute to the scientific process by sharpening our understanding of which effects are real, when they occur, and why. So hopefully by now I have sold you on how important replication is and the different ways we can do it to back up our theory. But despite its importance, replication faces several ongoing challenges within the scientific community. That's particularly true in fields like psychology and social science and behavioral research. One major hurdle is the publication bias that's against replication studies. Journals are often more willing to publish novel findings, something new and flashy, particularly those with statistically significant results. Often, replication studies are put on the back burner, especially those that don't reproduce the original effect. They didn't find anything. This bias means that studies which fail to replicate are less likely to be published, contributing to a skewed scientific record that overemphasizes the reliability of certain findings while downplaying the uncertainty or inconsistency that may exist in the original work. This issue is closely related to what's known as the file drawer problem. This is where studies with null or non-significant results are often left unpublished and they're metaphorically placed in a file drawer where nobody can see them. This again leads to a distorted view of the evidence available on a particular topic. And this can sometimes be bad because the lack of effect, finding that two variables are not related, is pretty important to know, right? Putting in a file drawer is committing this beta error here. Maybe there is something there, or maybe we want to know these variables aren't related, and we should stop trying to see if they're related because they just aren't. But if it doesn't get published, we don't know. Another significant challenge is the complexity and resource intensity of conducting replication studies. Replication of an experiment often requires careful attention to detail, and it requires also the ensuring that the original methodology is faithfully followed while accounting for new variables or contexts. This process can be costly and time-consuming, especially when studies are complex or require large sample sizes in order to achieve statistical power. Additionally, when replicating studies across different labs or cultures, it's difficult to control for every variable, which leads to variations in outcomes that may not always reflect the underlying effect being tested. There's also not a lot of glory in successfully replicating somebody else's study and saying, yeah, they were right. So there's really not much motivation there. And on the flip side, finding that there wasn't an effect and trying to publish that can sometimes get a little disdain and come by be looked down on, and people get flack. And even though you're trying to support the scientific community, people might get angry that you didn't support them because it might hurt their career if it's found that their maybe hallmark study wasn't necessarily replicable. So there's sometimes a little bit of politics in replication as well that we need to overcome. Lastly, there's the issue of theoretical ambiguity and boundary conditions, which we talked about. Many psychological effects have a when and for whom and where kind of caveats to the findings. So replication studies can sometimes fail simply because the original effect was context specific or it was influenced by factors that weren't adequately captured in the new study. For example, in the priming effects in the lab, this may not always translate to real-world behaviors, or it may depend on factors like individual differences in personality or prior effects, or how much the participants knew and were reacting to their knowledge of what was being primed. So when replication studies yield different results, it may reflect the difficulty of applying these broad psychological theories across a lot of variable settings or populations. And so it might basically highlight that the fundamental flaw is not in the original research, but it's in something about the new study. It's just unclear. So these challenges underscore the need for clearer theory building and more nuanced models in psychology, as well as a deeper commitment to understanding the boundaries of any kind of observed effect. So replication plays a critical role in the publication process and in the broader effort to build a reliable scientific literature. While publication traditionally favors novel, significant findings, there is now a growing recognition of the importance of publishing replication studies, both those that confirm original results and those that challenge them. Without space in literature for replications, science risks becoming a collection of one-off findings that may or may not hold up over time. By including replications in the publication ecosystem, this helps to correct for biases and validity and issues of reliability and reinforces the value of cumulative knowledge. There are, of course, several forms we talked about of replication that take within the research and publication cycle. There's the direct replications, which test the reproducibility of the results using the same methods, while the conceptual replications assess whether the same theoretical effects hold up under different conditions or measures. Then there's the replication plus extension, which goes further by combining replications with new questions and allowing authors to both validate and expand upon the original findings. Each of these approaches provides a different kind of value to the scientific record and should be considered publishable when designed rigorously. Of course, there are ongoing challenges in defining or evaluating successful replication and publishing. So we're dealing with that, but there are some initiatives like the registered reports format and journals dedicated to replication. These are journals that are helping to shift the norm. A registered report is when researchers submit their methods and what they're going to do, what all their hypotheses and theory that they're testing, submit it to a journal before they've done the study. The journal either accepts those methods and it goes through the peer review process, they accept it, and if they say, yes, this looks like an interesting study, we want to know the results of it, then the researcher does the study, and regardless of whether they found a statistically significant effect or an effect at all, the study gets published. So it basically skips any kind of file drawer and it automatically goes out. It removes this bias that journals have for the statistically significant findings. So by evaluating these studies based on their research questions and methodology before the results are known, these formats provide transparency and they reduce bias in what gets published. Now, incorporating replication more fully into the publication process ultimately strengthens the credibility of the field. It encourages researchers to prioritize methodological rigor, transparency, and theoretical clarity. And whether a replication confirms or challenges a prior finding, its inclusion in the published literature helps to ensure that science is self-correcting and continually progressing towards a more accurate understanding. So that's everything I have today about publishing and replication. Hopefully you learned a lot, and hopefully you're motivated and excited to take your work and build upon it, edit it, and do more research into the future. Thanks, everyone. Bye.